So to do that, let's start talking about trees. Unfortunately, not trees like this, but a bit more computer sciencey. And we have to start with a couple of definitions. So here's a tree. And the thing that has no, what we call parents, so no links going up, if you will, is the thing we call the root of the tree. And this root in this case has two children. And children, again, have parents. Right? So far, so family tree. Now, if a node has no children, we call it a leaf of the tree. So root at the top, the root has two children, child 1 has only one child, but this thing has no leaf or no children, so it's called a leaf. And the same is true for leaves 2, 3, and 4. Now, many different books, many different authors do many different things with trees, define them differently, but these I think everyone has in common: root, parent, child, leaves. Sometimes, however, people like to draw them the other way around. So the root at the bottom and the leaves at the top. A bit more like a tree in nature, maybe. But I will usually draw them like this, and so will the book. Now, just like in a family tree, we call nodes that have the same parent siblings. So in this case, child 1 and child 2 are siblings. Leaf 2, 3, and 4 are also siblings, but leaf 2 and leaf 1 are not. Then we have descendants. And we can find all of the descendants by repeatedly following child relationships. So the child of my child is also a descendant of mine. And a child of a child of a child of mine is also a descendant of mine, and so on and so forth. So repeatedly following such a child relation gives us all of my descendants. And of course, the other way around, repeatedly following the parent relation then gives me the ancestors. So for leaf 3, child 2 is its parent, and the root is the parent of the parent, so also an ancestor. Now these are some, let's say, common phrases when we talk about trees. The ones I will use most are the first 4 bullets, so root, parent, children, leaves, and siblings. I will not talk much about descendants and ancestors, but other books and other papers and other algorithms might. But in this course, you will mostly talk about children, parents, and siblings. So far, so good? Then let's talk about some other properties. And let's talk, for instance, about tree height. Something that I remember doing in primary school is something like this. And then you had to make the relation between A and B, would tell you something about the relation between C and the tree height, and so on and so forth. Great day out in the park, but as a primary school kid, I didn't learn much from this. Okay, let's see if we can define stuff like this for our trees. So, for starters, we have a property called depth. So every node has a certain depth, and it is the distance to the root. So the root itself, well, it's already where it is, so that has a depth of 0. But for instance, L2 has a depth of 2, because I need to make 2 steps to get to the root. So this is one thing, the depth of a node. On the other hand, we have the height of a tree. And the height of a tree is the length of the longest path from the root to a leaf. Where I consider the path a number of nodes rather than edges. So in this case, the height of the tree is 3. Why? Well, we have 1, 2, 3 layers in the tree, if you will. And now there is this important distinction between the depth of nodes, so these are properties that all of the nodes have, and the height of a tree, so this is the property that the tree has as a whole. Unfortunately, every book and Wikipedia and all kinds of other sources have very, very different definitions of the depth of nodes, of the depth of trees. Some of these people talk about. Some people talk about the height of nodes. Others only talk about the height of trees, but they say, no, it's the number of edges from, and so on and so forth. These are the definitions I will use in the course. But I will also try to make sure that if I ask you questions that relate to height or depth, it is clear from the question how we compute these things. For instance, on the mock exam that we are currently, I think the TAs will be done with it this afternoon, but fingers crossed, the mock computer exam that we are preparing, that you can use to practice, there is one question that says something like, give me all of the leaves of a tree that are at an odd depth. And we will include some examples to make clear which layers of a tree are at an odd depth and which one are at an even depth. But, for the record, depth 0, depth 1, depth 2. But the tree has height 3. Questions about the depth and the height? Depth of nodes and heights of a tree?